This is the Leaving Cert Ordering Level DEBmock 2020. This is Paper 1, Question 5, which is primarily looking at your ability to understand basic numbers put into scientific notation or standard form. It'll also be testing your ability to understand the idea of significant figures, rounding to decimal places, and also the idea of errors and working out a percentage error. A lot of the work would be done on your calculator. So let's work this way through this. So the speed of light is given to the nearest meter per second, and it asks us to put it in the format of. Now, whenever you see all this blurb here, okay, what it's basically saying is put it in scientific notation. So what is scientific notation? It's where there's a number between 1 and 10 multiplied by 10 to the power of something, and that something is a whole number. It might be positive, might be negative. Very large numbers, that power will be positive. If it were a very small number, it would be a negative value. So what we want to do is we want to take the most significant digit and work from there. So if we put a decimal point after the 2, after the first non-zero digit, okay, it'd be 2 point something, so 2.99, and we wanted 4 significant figures. So the fourth significant figure is up as far as the 7. Okay, so we're going to cut it after the 7. We'll look after the 7. Is it 5 and above? Yes, it is. That 9 there is greater than 5. So when we round this number, so 2.99, so instead of putting a 7, it'll be 8. Okay, that's my number. That's between 1 and 10. And all I have to do is then give it a sort of a size, a magnitude, so it's times 10 to the power of. So how many places after where it is at the moment, which is between the 2 and the 9, how many places would it be to get down to after the 8? Or you could see it's being, currently it's here, we're moving it to here. How many places do we move it? We move it 8 places, therefore it's times 10 to the power of 8. Okay, I've put it in the correct format of 4 significant figures times 10 to the power of. Find the percentage error in using your answer as an approximation of the speed light instead of the actual figure. So what we're saying is we've rounded this basically. We've rounded it to 299,800,000. So how close is that? What is the error that I've created by rounding it to 4 significant figures? So first of all, let's work out what the actual difference is. What is the actual error? So if we consider the number we actually rounded to, which was that, and if we subtract the actual value, we end up with an error that is 7,542 meters per second. Okay, the units aren't that important at this stage. That is the actual error. That's the difference. Okay, so a percentage error is worked out by saying, well, what is your actual error? Divide it by what is the error? Divided by the actual value, the correct value, and times that by 100. So in this instance, my error is 7,542. The actual value is 299,792,458, and whatever that number is, if I multiply that by 100, I end up with 0.0025, okay, correct to 4 decimal places. It's actually 0.00251574, but we round it to 4 decimal places. So 0.0025%. Very, very small amount. Okay, it's so much smaller than even 1%. Okay. And there were 10 marks for those 2 questions, 2 5s, 5 and a 5. So now moving on to part B, find the speed of light, okay, in kilometers per hour. So we have to be careful. First we're dealing with meters per second, now we're dealing with kilometers per hour. So how do we work that out? Well, we know what the speed is in meters per second. we want to convert that into meters per hour and then kilometers per hour. So meters per second was the 299,792,458. If I then want to work that out in meters per hour, I have to multiply it by 60 and 60 again. So I'm not even going to bother writing out what that actually is as a number. Okay, the key thing is that's meters per hour, so it's an awful lot more than you would do in a second. But we now want to convert that into kilometers. Now, kilometer is 1,000 meters. So if I this answer here, which would have worked out as 1079252848,800. Okay, I want to divide that by 1,000. So effectively, we're going to move the decimal point. I'm going to round it to the nearest whole number. So we end up with 1079252848.8, and we're going to round that 1079252849. So just think about that as a number. It's 1,079,252,849 kilometers per hour. So fairly fast. And that was worth 5 marks. Just very quickly, in terms of this process, being able to sort of get through from converting from meters per second to kilometers per hour, there is a quick way of doing it, and it is the process of just multiplying by 3.6. Okay, that would get you the times by 60 divided by 1,000. Moving on to part C for 10 marks. We have a question where we've been given a time. We already know the speed, okay, and we're asked to work out the distance. So this is bringing in your understanding of Dad's silly triangle, basically the relationship of distance, speed, and time. So distance is equal to speed multiplied by time. So we know what the speed is. We're given in meters per second. We're given that it is 299,792,458. Okay, and we multiply that by the time. Now, just very quickly, what will the time actually be? Well, it's 8 minutes and 19 seconds. So 8 minutes, okay, 8 minutes is 8 lots of 60 seconds, okay, which is 480. So if I add on the 19 extra seconds, we end up with 499 seconds. So why am I using the original speed that I was given? Well, I've got my time in seconds, so therefore I must make sure my speed is involving seconds. That's why I'm using the meters per second. Okay, times by the 499, and that works out as 149,596,436,542. Now, that is meters. Think about it. I multiply meters per second by seconds. So what I'm left with is meters. So the final step I have to make is I have to round it. So I have to change it into kilometers. So for that, I'm basically going to divide by 1,000. Okay, so it's going to be 0.542. What have I done? I've moved it 3 decimal places. I've divided by 1,000. So as a result, I've got that answer there. Now it asks me for it to be two significant figures. So the first significant figure is the 1. The next significant figure is the 4. I always look at the next digit. The first one I'm not going to use. Here it's 9, so I have to round it up. So I get 150,000,000,000. So it's 150 million, okay, kilometers. And as I said to you, that was worth 10 marks.